Hey, everybody. So, uh, what was due today is the graphing exercise 2. Graphing exercise 2 is due today, the day that I'm making this video. So, hopefully you did that if you hadn't been here. And like what you see here on the screen is that graph of distance versus long run, which is how the graph is set up. Distance is how we normally say that, the y variable, distance versus long run. Okay, again, measured in weeks and then measured in miles for distance. So the slope of that, I hope you found it to be near 1. Now, for me, at 14 and a half over 14 and a half miles over 14 weeks is actually 1.036. What the? I got this thing frozen on the wrong. Oh my gosh! There we go. It's actually 1.036 miles per week. Now, oh my gosh! So, not exactly 1, but again, pretty darn close. And so, just for ease of this process, I just made it 1. Now, what I had seen from some folks is that I'm still seeing some folks connecting the dots. Please do not connect the dots. Like, I know this data is not perfect. Like, these two right here seem to be perfectly connected. And then even this one right here. So 3 of them, the line literally passes right through the center of the dot. Notice I've got 1 above here. I got a couple below. I got a couple above, and then a couple below. So again, I'm splitting right down through my data. Is kind of the goal is to split right through the center of where your data is. Now I'm seeing some folks with their best fit making it curve to follow the points. No, you cannot curve them to follow the points. That's not how it works. It's either linear data or it isn't. Like for us, we're dealing with mathematical relationships in graphing. And so let me pull up a slide here that oh here it is. So we're dealing with y equals mx plus b. Okay, that is a graphing relationship for a linear function, a straight line graph. Okay, now that's not the only kind of graph though. And so these graphs here, like we could have, this one here is known as a top opening parabola. It's open at the top. And this would be a y equals mx squared plus b relationship. This one here, a side opening parabola, that'd be a y squared equals mx plus b. And then we could have an inverse curve, which is a y equals m 1 over x plus b. So these are other mathematical equations or relationships that could show up in data, but we haven't seen those yet. We're seeing linear stuff, okay, with y equals mx plus b. Mathematically, these things are a little too complicated for us to deal with, and so we're sticking with the simple stuff. Not saying we'll never see these. We will, and we'll hopefully be able to recognize them for what they are. We probably won't do a whole lot of math stuff with it. Now, if you take physics as a senior, then we'll dive into all of this stuff, and by that time, hopefully, you either will be in pre-calculus or have already been and are in calculus, and so you will have the mathematical basis for us to be able to do this kind of thing easily once you're seniors. But for now, we're sticking to the simple stuff. We're only looking at linear functions or linear relationships, okay? Directly proportional so far. Now, let's see, where was I? Right here. So let's just start going down through the list here. We have, what is the name of the variable on the y-axis? Well, that's distance, which I told you to put that there. What is the name of the variable on the x-axis? That's the long run. Again, each week goes by, and that's the long run. Then you're supposed to replace the y and the x in the equation with the names of the variables. So I put distance in for the y, and I put long run, or abbreviated it LR, for the long run, which goes in for the x. M and the b are still symbols. We haven't put numbers in there because the questions haven't even asked you yet for slope. I went ahead and found slope first because we always end up needing the slope. So I always just do it automatically first before any question is even asked about what the slope is, just because I know I'm going to need it. So I just do that. So that's the first three questions. And then we move on to page 2, which is, let's see here. So it says slope and show your work. Well, I did that earlier. You should be showing it here, in this section. Now, again, you don't have the actual hard copy of this thing, so you're doing all this in your comp book. So I just assume that you probably have shown your slope work somewhere, like on the graph. So that's that. Again, around 1 mile per week, hopefully, is what you saw. Which means what? What is that actually telling us about this data and about the runner who was coming back from injury here? Now, some folks had said that means they're running a mile a week. Well, it's actually my data. It was actually me. I'm the one that did this. So it's not me running a mile a week. It's me increasing my distance by 1 mile every week. So I didn't just run 1 mile every week. The data shows that because each week the long run was getting longer and longer and longer. And it was getting longer by how much? Well, roughly a mile longer each week. I hope you see that. Then you're supposed to replace the m in the equation with the actual slope value. So I put that in there. And again, remember, mine's 1.036, so I just didn't worry about the 36 thousandths. I just left that off, which we will see in a minute here. Maybe I shouldn't have. So distance, I got my slope in here, got my LR, my long run, and plus B, which I haven't done yet. Then I was supposed to look at where the line crosses the y-axis. Now, from everyone first period so far, everyone first period had a y-intercept less than 1 mile. Less than. Mine is as well. Mine's 0.4 miles because mine's, I think, a little less than halfway up the first box. And so if I look back at my graph here and I look at where my line crosses, that to me looks like it's crossing just less than halfway up the first box. That's what I think. Yours is probably somewhere in there too. Again, if my first box is for a mile, I would assume most of you have your data less than 1 mile. Now, here's the question that we tried to answer for that. Oh, I went too far. There we go. What does that mean? Like if your y-intercept is 0.4 miles like mine or whatever, what does that actually mean? Because that's the next question. What does that mean? What does that y-intercept tell you? Well, I hope you remember the sentence that you were supposed to write down from before. Oh, let's see if I can find it. That the y-intercept, where is it? There we go. The y-intercept is the value. So if you haven't written this down yet in your comp book, I would write this down somewhere. The y-intercept, the meaning of the y-intercept, it is the value of the y variable when the x variable is 0. Value of the y when the x is 0. Okay, so let's look back at the equation here that we were writing. So at this point, the value of the y, which is distance, the value of the distance when the long run is 0. When is the long run 0? I mean, if we look at the data, like long run is measured in weeks. When is week 0? Like at the beginning, like I hadn't even started yet. At week 0, how far did I run? Probably 0. I hadn't run yet. So what should our y-intercepts be? Probably close to 0. Is 0.4 miles close to 0? I mean, it's less than a mile. That's not very far, right? That's small. So maybe our y-intercepts should be 0 because look what happens in the equation here. When you put 0 in here, well, let me go ahead and write the equation out. So this is the equation written out with the y-intercept in its place. If you put 0 in here, 0 weeks for the long run, 0 weeks times 1 is 0. Plus 0.4 miles means my distance at week 0 would be 0.4 miles. Which again, if I hadn't started running yet, week 0, I didn't have a long run. Like there is no, because the long run, and here's the way this works. The long run usually happens at the end of your training week. So you do a couple of short runs, and then you do a long run at the end of the week. And then you start over again, and you do some short runs, and then you do another long run at the end of that week. So at week 0, I hadn't even had a week yet. I'd been injured for 3 months, and so I hadn't run. So there shouldn't be a long run at week 0 because I hadn't run yet. So 0.4, okay. Maybe it's because my data is kind of messed up and that's a little bit of error. Because sometimes our y-intercepts mean that we have some error if we have one and we think we shouldn't have one, the y-intercept. Now in the last one with the baby and the weight and the height, or the height of the baby, each year, that one, we did have a y-intercept. Again, it was around 21 inches-ish. And that meant something very important. That was, the height or the length of the kid when it was born. So that had a very specific meaning, and we should not have had 0 for a y-intercept there. Here, if I hadn't started running yet at week 0, then I probably shouldn't have a y-intercept. So maybe I should have 0 here. But again, maybe there's a little bit of error in these values. And so it's saying I ran 0.4 miles when I hadn't even started running yet, which maybe that's some error. Or maybe this is like at the beginning of the first week, like the first day. Maybe the first day of running again, maybe I ran 0.4 and then slowly increased until at the end of the week I was at 1.5 miles, which I think is what the data is. Yeah, 1.5 miles for my long run. Maybe that happened, but early in the week, I ran like 0.4 and then increased, and then finally got to 1.5 miles at the end of the week. I don't know. Maybe that could be the case. But we have to have some way to try to explain what the y-intercept is and what it means. I hope I'm making sense and I haven't lost you. Okay. Either way, it's a very small y-intercept. Not a lot of distance if you hadn't started running yet. Hopefully that makes sense. Then number 9, you're supposed to figure out what is the long run from week 6. Well, from the graph, can you figure that out just by looking at the graph? Can you figure that out by looking at the graph? So what do? Well, you go to week 6 and you start at week 6 and you go all the way up to the line and then you head over to the left. And it looks like I'm just over halfway up the box from 6 to 7, just over halfway up. So I would say about 6.6. That looks to me about 6.6 miles if I was estimating. Now, can you read that off the graph and then that just be your answer? Yes. Well, then how do you explain, because the question asks you to explain, show how you got this answer below. Well, I would just say, well, I went to the graph at week 6, went up to the best fit, went over to the left, saw the distance was 6.6 miles. That's all you have to do. Just explain what you did on the graph, where you looked to get that answer. Or you could use the equation. So if you put 6 weeks in for your long run, so the long run is the 6-week long run, times your slope, week here cancels week here, and we end up with just miles. And so 6 miles plus your 0.4 y-intercept is 6.4 miles. Well, that's pretty darn close to 6.6. So the equation is telling us the same thing as the graph. Now remember though, I did not use, my actual slope was not 1. It was 1.036. If I use my slope of 1.036 here times week 6 plus 0.4, you know what it comes out to be? That right there, 6.16 miles. The exact same thing as what my graph told me. So this equation is the equation of the line. It should tell you the same thing that the graph itself tells you. Okay. If you have found the slope well and you estimated the y-intercept correctly, then it should tell you the same answers. Now, for number 10, we don't have week 22. The data doesn't go out that far. And my graph doesn't extend that far either. So I can't read the graph for this one. I have to use the equation for this one. So I put 22 weeks in, 22 weeks times 1. Again, weeks cancels weeks. 22 times 1 mile is 22 miles, plus 0.4 would be 22.4 miles. Well, then I went ahead and put my 1.036, I put that in instead for one, in place of 1, and I found it to be 23.192 miles. Now, that may not seem like a lot. Again, it's 0.7, almost 0.8 miles different. So is it significant? Does 36 hundredths end up adding up? Yeah, it does, which I hope maybe you will realize that when you round an answer or a measurement, or when you take a measurement and don't do it very accurately and you just kind of eyeball it and estimate badly, poorly, that will have a major impact on what your results are going forward. So make sure when you are collecting data and when you're measuring things and when you're doing calculations that you do it with a certain level of accuracy, right? That you're paying close attention, and then precision, especially when you're talking about measuring with a meter stick, that you're not just saying, well, it looks like about 6.5, when in reality it's like 6.2, or you say, well, it looks like about 21, but then you look at it a little closer and it's actually 21.7. So those little fractions here and there that you're not paying attention to, they add up over the long haul here. So I hope that maybe this will encourage you to be a little more detail oriented and not step back and look with such a broad view, but you would look a little closer and be a little more specific. So this hopefully makes sense to you in terms of the data, making a graph, finding a slope, writing the equation, and then using the equation. This is what we're going to be doing. All right. So we changed gears from this. Then we started talking about the new, like what we were doing after that. And that was circles. Oh boy, which slide is it? I think it's this one. All right. So I decided, hey, I like circles. I'm going to move myself around here. So circles around, very neat. I like circles. So the question is this: what is the relationship between around and across for circles? Because you see, circles have two different dimensions you can measure. It's how far around are they and how far across are they. And so I want to look at those two dimensions for a bunch of things that are circular. All right. And so we did that in class. And we decided that for this, we should have 7 or 8 data points at least. Once you get up past 8, toward 10 or more, then it becomes cumbersome and just probably too much. If you go less than 7, then I don't think we get a clear enough picture as to what the relationship is trying to show. Okay, so really 7 or 8 is kind of the sweet spot for data. The other thing that we need to keep in mind is that we need a large range. And what I mean by that, we need data to be big all the way down to like small stuff. Okay. So here's what we ended up doing. And for each class period, so this video will be posted, of course, and then look for the actual, should be a screenshot of your data from your class period that I will post as well. So your data from your class period will be posted so that you can actually use it, and you will make a graph of the around data and the across data. And you will put it on the appropriate axis the way I've labeled this one. And then you will find a slope, and you will look at the y-intercept, and you will write the equation out like we've done the last couple of times. Only now it's going to be for data that you've collected as a class and used. Now, to measure the around, the groups have strings. So we're going to wrap a string around the object and then measure how long the string is. And then, of course, we have meter sticks to measure the across. And there's a whole list of different things that we measured. So I will be posting that as well as this video, so you can have the data if you're at home, to be able to put your graph together. Now, what happened is each group, and again, it's things like an expo marker and a bucket and the base of a graduated cylinder, and there's a little white cap that goes on a little vial, and there's a golf ball and a softball, and so there's a bunch of different stuff that we had to measure around and across, and then each group measured each object twice. Or I should say each group measured 2 different objects, and then we averaged those. So again, I hope that the data when I post it will be clear. You're using the average values, okay? The average values are what you will use from your class period. And I'll try to label it well so that you know what's going on. And again, so you'll take that data, make a graph, find a slope, write the equation for that stuff. And that's what we're going to talk about the next class, all right? So that is, now I didn't make an assignment. I didn't create an assignment for it. It's just what you need to do for the next time we get together, and then we'll talk about what you saw, what you observed, and what we think about this. What is the relationship between the around and the across for circles? What is that eye doing there? That's bizarre. What on earth? Anyway, I hope that I've made sense of this. All right. So anyway, if you're not here, hopefully you get back soon, and we'll see you hopefully as soon as possible. Take care of yourselves, and I'll see you next time.